Greetings once again. So last time we were together, we talked about solving some triangles with the law of sines, which you see up on the top left of the screen here. And remember the law of sines, anytime we have two angles and any one side, then we can do what we need to do to solve for the last angle. That's always easy. And then set up the ratios, cross multiply, divide, and then find the other two sides. And that's all well and good, but obviously that's not all the different cases that we can do. So we also need to find a way to solve some triangles if we just know all three sides, or in some cases if we know two sides and the included angle. And that's where the law of cosines comes in. So we're going to talk about solving some triangles with the law of cosines today and see how that works algebraically, and then how to put them in the calculator also to make sure we get our final answers. So when do we use the law of cosines? Again, using the same convention that we used back in geometry. SSS is our side case. Anytime we have three sides, as long as they make a triangle. And then the SAS case, side angle side, again, that's two sides and the included angle. And I'll talk more specifically about what that means in just a couple minutes. So what does the law of cosines look like? It was on that previous screen, but here it is here. And if you need to pause the video for just 1 second so you can jot that in your notes, by all means. Notice, it's really the same law. It's just a matter of the arranging of the letters. But there's a couple of things I want you to notice. One, it should look a little bit like the Pythagorean theorem, and that is kind of how it's derived. Two, I want you to notice the corresponding angles that are in each formula. In other words, if you know angle A and side A, and then side B, angle B in the same formula, and then side C and angle C in the same formula. So as you get familiar with using the law of cosines, it really sets up the same way. It just depends on kind of what you know and what you're trying to find as far as which formula you're going to use. Okay? So let's go ahead and jump into the first example here. And the first one is going to be a side case. So, excuse me. So we can sketch this triangle if we want to. I'm not going to do anything of high artistic value here, but so we have A, B, and C, then that means side A is 15, side B is 22, and side C is 31. And we just need to find all three angles. Now, it doesn't matter which angle we find first. I'm going to find side A just because it's side A. So I go back to my laws, and I'm going to use, and since the only one that has angle A is the top one, I'm going to use that law. So I'm going to plug everything in. So I know that 15 squared is equal to 22 squared plus 31 squared minus 2 times 22 times 31 times the cosine of A, which is what I'm trying to find. And then from here, I am going to use my algebra. Now, depending on what kind of calculator you have, and most calculators these days can do this with some kind of NSolve or solver technique, we're not doing that. We're doing the algebra by hand, and then we can use the calculator as a tool to get our final answer. But we're not going to take the shortcut on just kind of popping that in there and letting the calculator do all the work. Because look, when we solve this thing for A, it's always going to be that same kind of pattern. If you think of it algebraically, I'm going to move the 22 squared across, move the 31 squared across, and then divide by this whole quantity here, and all of a sudden cosine A is by itself. And we know from the previous unit, whenever we want to find an angle, we can do the inverse cosine, and it'll give us of that whole quantity, and it'll give us what the measure of the angle is. Okay, so I'm going to do this all in one step. So I know that angle A is going to be equal to the inverse cosine of 15 squared minus 22 squared minus 31 squared, all divided by -2 times 22 times 31. Okay, now I don't care about seeing all of the other steps, to find what those specific things are, because that's for heaven's sakes, that's why we have calculators. So I'm not worried about that, but I do want to see that step to make sure that we're getting everything isolated so we can solve for A. Once we have angle A, we can do the exact same thing for angle B. And so what would that look like? We're going to actually, let me go ahead and show you what the measure of A is real quick. So A, here it is where I put in the calculator. Now notice my calculator is set up in radians. So if we want the final answer in degrees, we need to multiply this by 180 over pi. And so my final answer here would be 26.57 degrees. So that would be my angle A. Okay? So that's kind of what you do each time, right? So what angle do you want to find first? Doesn't matter which one. Use the appropriate law, solve it. Don't forget to convert back to degrees. And then we're going to do the same thing for angle B. I'm going to move this down a little bit so I can kind of get it out of the way. I'm going to do the exact same thing for angle B, find that one, and then for angle C, it's just going to be a matter of subtraction. So let's see here. So we know that if I'm going to find the angle B, we know that 22 squared equals 15 squared plus 31 squared minus 2 times 15 times 31 cosine B. And again, doing the exact same algebra that we did before, B is going to be equal to the inverse cosine of 22 squared minus 15 squared minus 31 squared, all divided by -2 times 15 times 31. And again, if you need to pause the video for 1 second to make sure you see where all those numbers are coming from and then how the algebra works out, as you find the angle, by all means, please do that. But when we do that and pop that into our calculator, we have that. And again, radians, depending on how your calculator is set up, I'm going to multiply that by 180 over pi. And then my last angle here comes out to be 40.99. And then once I have that, so I've got my angle A right here, and I got my angle B right here. Now, for heaven's sakes, let's not do too much work here. Once I have that, then I know that angle C is just going to be equal to 180 minus 26.57 minus 40.99, which will come out to be 112.45. So once you find that once you find the second angle, the third angle is just a matter of subtraction, assuming everything kind of went well on that. Okay. So for the SSS case, you got to do that. You got to do that algebra twice to find the two angles, subtract, and then you have there. And again, even though the AP standard is 3 decimal places, as long as we go to 2 decimal places in class, I think I'll be okay with that. Okay. Let's take a look at one more example on the SAS case. So this is an SAS case. Again, 2 sides in the included angle. If you draw this triangle, again, just a rough sketch of this thing. Angle A is 40 degrees, side B is 13, and side C is 21. And you see that that is the included angle between those 2 sides. I'm going to do another video moving forward on the non-included angle case, which is called the ambiguous case, but we're going to handle that one kind of separately. Okay, so what do we do on this one? Well, if you go back and look at all of the different laws of cosines and you see what you have, I think you'll notice you are locked in to finding the third side, because that's the only thing that you have everything except for one variable. So we're going to go ahead and find side A, and we know that formula is a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of 40. And this is just a plug and chug. Everything's on one side of the equation. All we got to do is make sure and take the square root of it at the end. So a is equal to the square root. I'm not even going to write that whole thing back down again, because at this point, we're just going to pop that in the calculator. So I go back to my calculator. I got that set up already. And so we see that the side is 13.85 on the top line there. Don't look at the second line just yet. So 13.85 is my side A. And then once I have that, then I can just move on just exactly what I did before in finding the angles. So again, I've already got angle A, so I'm going to go ahead and find angle B. So I use the law of cosines that has angle B in there, so 13 squared equals A squared, which what I just found, so 13.85 squared plus C squared minus 2 times 1385 and 21 and cosine B. And again, doing that algebra, and I'm not even going to write that down because we know how to do that from the previous example. So we know that B is equal to the cosine inverse of that big old fraction that we know how to do that. We pop that in the calculator and turn it back into degrees. Never forget that in case you need to. So again, that's what's on my second line right here. And then we convert that to degrees. And we have 37.12. And then once we have that guy, so again, we have our side A, we have our angle B, and now for angle C, we can just do the subtraction. So it's 180 minus, we know A was 40, minus 3712. So C will be equal to 102.88. So what are our steps for the SAS case? Again, you're locked in to find that third side. Use the appropriate rule. Don't forget to square root it. I see that quite often. Find the second angle just like you did for the SSS case. Convert and then subtraction. Okay, so I'm going to go to one more blank problem. I'll leave this up here for just 1 second in case you need to write anything else down. I'm going to go to one more problem. I'm going to have you do this on your own. You can pause the video as soon as the problem comes up. And then I'm not even going to do the algebra on that one. I'm just going to show you the answers, and you can check your own work. So here's the last one. You're given side A is 32, side C is 22, angle B is 55. Again, just to verify, if you sketch a triangle again, so 55 degrees, side C is 22, side A is 32, and again, that's our SAS case. So the law of cosines applies. So go and pause the video for a second, work through that one on your own. And I'm going to zip through the answers real fast. All right, so again, on this one here, hopefully you have the answers, or at least have everything set up. And even on the calculator, I'll show you on the calculator, I've got everything set up for you. here's what you have to do. So we know we have to find side B first. So we do that with our square root deal. And that is right here. So the top line, side B is going to come out to be 26.42 degrees. Angle A is here on the second line. So again, in the inverse cosine of all the values that we need for that formula, again, that's in radians, converted back to degrees, 82.07. And then on the last line, you see we're just subtracting for the third angle, which is angle C. So my final answers on this one will be, excuse me, side B would be equal to 26.47, angle A 82.07 degrees, and angle C came out to be 42.93 degrees. So that's an overview of the law of cosines. There'll be one more video coming up shortly on the ambiguous case, which is two sides and a non-included angle. I will also, there should be a link up on the video right now that'll link you back to the one on the law of sines for the two angles and one side case. And then once I get the other, that last video done, I'll link to that one as well in the description. Thank you again for watching. Don't forget to subscribe if you want to see some more videos moving forward. And we will see you next time. Have a great day.